go with the next concept. So that is static friction, which we have already discussed. So static friction. So when an object is at rest, so what will happen when you apply a small amount of force? What will happen? Body will be remain at rest. As you go on applying the force, then also you find body at rest. That means there is some opposition in the beginning. As the applied force go on increasing, this opposition also go on increasing. This opposition is only called as what it is called as the friction or frictional force. As your applied force is increasing, friction force is also increasing. So that is why it is called as what it is called as the self-adjusting force. Okay. So when it reaches some value, that we call it as the limiting force of friction. When your force applied external force reaches limiting value, so body, what will happen? It will just starts moving. Okay. So just slides. Okay, so just slide. It is start to slide. So then this value we call it as what? Limiting force of friction. Okay, so this is what all of us we have discussed, and how we can calculate your friction. Friction is, as you already know, directly proportional to what? Normal reaction. Okay, so which is equals to m into g, which is in downward direction. Okay, so F you can write it as mu s into normal. So mu s is what it is, the coefficient of what is that? Static friction. Coefficient of static friction. Okay. So this I will take as Fs because of static. Then what is the limiting value of friction? The maximum value of friction or maximum value of static friction. We call it as what? We call it as limiting value of friction. And this is equals to what? This is equals to mu s into n. Your maximum value of static friction is always equals to what? Mu s into n. If the friction is just little more than this maximum value, then what will happen? Body will start moving. Okay, so that is why your static friction is always less than or equal to mu s into n. Okay, that means it is always less than or equals to maximum value. So maximum value is equals to mu s into n. So that is what the static friction is always less than or equals to mu s into n. Okay, so for example, suppose there is an object. Okay, so these values are the standard values they will use. Suppose for these two surfaces, mu s may be say 0.5 and mass of body is 2 kg. So what is the normal reaction? G is what? G I will take as 10. So normal reaction is equals to what? M into Z. That means say 2 into 10. So this will become what? 20. Okay. So now if you apply some amount of force, okay. So if applied force is say I will take it as say some 2 Newton. Okay. We already know what they are asking. What is the frictional force at this moment for this structure? What is the static friction they are asking? As we know, as if you apply little force, what will happen? If you apply 1 Newton force in this direction, friction is opposite to that one. If it is 2 Newton, again what will happen? Friction will increase. Yes or no? We may think that if 2 Newton force is there, the opposite or static friction is also maybe 2 Newton, but we cannot guess like that because if applied force is more than mu s into n, that is maximum value, then you can't take that as the static friction. Then it will become what? Kinetic friction. So that is why before taking this value as static friction, you have to check what is the maximum static friction for this one. What is the maximum static friction for this moment? For this moment, SS maximum is equals to mu s into n. Mu s is what? 0.5. N is what? N is 20. So what will happen? This will become 10 Newton. Yes or no? So this 0 will go. So 5 into 10 Newton. So maximum value is what? Maximum value is 10 Newton. That means applied force is what? Less than the 10 Newton. That means applied force is less than maximum value of static friction. till reaching the maximum value of static friction, the friction is equals to what? Friction is equals to applied force. Okay, so now you can take the friction or static friction is equals to for this force, static friction is equals to what? It is 2 Newton only, because applied force is less than maximum value of friction. Now instead of this one, I will apply say 5 Newton. So what happens to the static friction? Static friction will also increase. When it was 2, static friction was also 2. When it is 5, now static friction will also 5. Why? Because 5 is less than 10. Till it reaching the 10, the static friction is equals to what? Applied external force. So if you apply 5 Newton, so static friction will become 5 Newton. If F equals to 5 Newton, this is what when F equals to 2 Newton. Okay. If I apply the some 8 Newton, obviously static friction is going to be what? 8 Newton only, because static friction go on increasing with the applied friction. Okay, applied force. Okay, so if I apply F equals to 10 Newton, obviously static force is also 10 Newton, because Fs is less than or equals to maximum. Maximum value is this one. Now if you apply F equals to 12 Newton, you cannot write this equals to 12. Why? Because the maximum value what? Maximum value is only 10. How you can go with the 12? Okay, that means if this is the situation, you can write static friction maximum is equals to 10 only. It is not going to 12. So remaining 2 Newton will be what? That may be some other form. It may be some other frictions. Okay. So the body starts moving at 10 Newton. Immediately after 10.001, it will start moving. Once it starts moving, there is no static friction. But what they are talking about? They are talking about static friction only. They are not talking about kinetic or something. So we have to check the value of static friction till body starts moving. When body starts moving, when applied force become 10 Newton. Till then, 1 Newton, 2 Newton, 3, 4, 5, 6, 7, 8, 9, 10. Till 10, your friction is also 1, 2, 3, 4, 5 like that. How much you are applying? That much friction. When you apply 10 Newton, the maximum static friction is also 10. If you apply 11 Newton, friction is not 11 Newton. So friction is going to be, static friction is going to be 10 only. Okay, because we have to check the friction before it starts moving. Okay, so this is how most of time we do attempt mistakes while calculating the static friction. Or whenever they ask static friction, people will do μs into N. No, it is not like that. It all depends on the maximum value of the static friction. Okay, so for example, if I take another example, suppose there is a train moving, and this is what one compartment of the train. So inside this there is a box. Okay, there is a box. Say it is of say some 1 kg or some 5 kg. Okay, it is of say some 5 kg. Okay, so 5 is a very high value. Let me take 0.2 kg. Let it be 5 kg. Okay, so now suppose this train is moving. When this train start moving, listen properly. When this train start moving, the object is at rest now. What is its tendency? Its tendency is to be remains at rest according to Newton's first law. If this body starts moving, this body will not move, because the force is applied on this one, not on this one. So it always tries to be there where it is. Okay. So when a train comes here, when train comes here, suppose train comes over here. So the box should be here only, that should fall down. But in practical it is not happening. Box is also moving with the train. What is the reason for that one? Which force is doing that? When the train start moving in this direction, what will happen? The box try to remains here, means it try to be moving this direction. But because of friction which opposes this motion, that will bring that body with the train. Okay, there is a friction. When train start moving in this direction, what is here? It try to be come on this side, but because of friction, if it want to try to come here, so friction will what? Friction will oppose this one. If it opposes, so that is also moving with what? That is also moving with the train. So that is why So reason here, whenever you put up boxes on the, or you are sitting on the train, or your boxes are kept on the some goods or vehicles or something, they all are moving because of the friction between that box and surface. Okay, now suppose the train is moving with, say, with the acceleration of 1 meter per second, but very small acceleration I am taking. If train is moving with 1 meter per second, now we can check what we can check. This body is of this one. The frictional static friction, say you can take it as mu s as 0.5 only. Okay. So now what is the frictional force? What is the frictional force we have to calculate? Okay. So how we can calculate the frictional force? Frictional force Fs is equals to maximum frictional force. Maximum frictional force is what? Maximum frictional force is mu s into n. What is mu s? Mu s is say mu s is 0.5. N is what? N is m into g. So 0.5 into mass is what? Mass is how much we have taken this box? So 5 kg something. Okay, or you can take it as 2 kg. So 2 kg into this is what? 10. G I am taking it as 10. So now what will happen? Again this will become what? 10 Newton. Okay. But this is not the friction. Again, this is what the maximum value of friction. What they are asking? They are asking what is the value of friction? What is the friction between this and this one? This is what? This is the maximum value of friction because mu s into n. Now we can calculate the friction. How we can calculate? With what force it is moving in this direction, the same force will be the friction. Getting the point? So same force will be the friction. This is what the force of the train. So what is the force of the train? Force of the train is force on the train is mass into acceleration. Not on the train. If it is also moving with box, I will take on the box. Okay. What is the force on the box? Force on the box is mass of box and acceleration. Acceleration is of box is equals to what? Acceleration of train, because box is moving with train. So that is why mass is 2 kg, acceleration is 1. So 2 into 1, 2 Newton. So this is what the force on the box. What is that? It is trying to be here. So how much friction will develop? Friction will develop equal and opposite to that one. So that is why force is equals to friction. I will write it as static friction is equals to 2 Newton only. Why? Because 2 Newton is less than 10 Newton. This is maximum friction possible for this box on the surface of this compartment of train is what? 10 Newton. Till 10 Newton. Whatever the force because of motion of train acts on the body, that is what equals to the static friction. So 2 Newton static friction, 3 Newton static friction, 9 Newton static friction, 10 Newton static friction. If it become 11, static friction is again 10 only. It is not going to be 11. So this is what, as of now for this example, the static friction is going to be 2 Newton only. Okay. So this is how we can calculate the static frictions by applying the condition that whether applied force is less than or equal to the maximum static friction. That is what mu s into n. If it is less than, go with the applied force. If it is more, then you have to go with the maximum static friction value. So next, one more important friction, that is what when body starts moving. At that time the friction comes in action. We call it as what? Kinetic friction. Okay. So that is what we call it as kinetic friction. So what do we mean by kinetic friction? Okay. So what will happen in case of static friction? So this friction was what? It was holding the body, and body was at rest. It was not allowed to move. After reaching some value, it will start moving. Okay. Once it starts moving, according to Newton's third law, according to Newton's first law, it keep on moving. It should keep on moving. Okay. So beginning it was not moving because of the reason you are given, frictional force was there. So that is why body was not moving. So net acceleration was 0 because of equal and opposite forces were acting. Okay. Once you cross the maximum value of friction, what will happen? Body starts moving. once body starts moving, it should keep in motion according to what? According to your first law. But what is happening when you look at the body, when you want to apply some force and you remove that extra force, when you look at the body is not continuously in motion. After some time, what will happen? It will comes to rest. Why this body is coming to rest? Because you are not applying any opposing force. Once body is moving, it continues to be in the state of rest. It continues to be in the state of what? Motion. But here, body is coming to rest unless you are not applying any opposing force, which can stop. Without applying any opposing force, then also it is coming to rest, means there may be something is opposing when body is in motion. When body is moving on another body, there may be some opposing force. So that is why body is coming to rest without any external force. Okay, so external force is not there. So to compensate this one, that is what we assume, that there may be some opposing force. So that force is what? Nothing but again it is a frictional force. It is the friction. Since this friction is coming in action when one body is moving over the another body, or one body is sliding over the another body, so that is why it is coming when body is in moment. So that is why it is called as what? It is called as kinetic friction. So how we can define the kinetic friction? You can define kinetic friction as the force of friction. The force of friction which comes in action, when one body or object, when one body moves over the surface of another body. The force of friction which comes in action when one body moves over the surface of another body is called as what? Is called kinetic friction. Is called kinetic friction. Okay, hope you got what exactly kinetic friction is. Okay, so now how we can measure this kinetic friction? Okay, a body is moving. Say a body is moving with some constant velocity. Say its mass is m. Now how we can apply? How we can get the what exactly the kinetic friction? I will denote it by Fk. Kinetic friction. You can denote it by Fk. Static friction Fs. Okay. So now when body is motion, then also there is a normal active on this one. Yes or no? Obviously, normal is active. As we know that frictional force is directly proportional to what? Normal. So similarly, kinetic friction is proportional to normal. We can write Fk equals to mu into N. But in case of static, we had taken mu S. Here we have to take mu K. This is what the kinetic coefficient of kinetic friction. In case of static, it was mu S, coefficient of static friction. Okay. So what we can write? Mu K. Mu K is equals to coefficient of kinetic friction. Kinetic friction. Okay. So now what is N? N again, as it is a normal reaction. Normal. You can write it as N equals to M into Z as it is. Then you may ask me, that is also F equals to mu into N. This is also F equals to mu into N. What is the difference? We may get same, but these coefficients are not same. That was mu S and this is mu K. They are not going to be same. They may be different. They are different for static and that is different for the kinetic. Okay. So with the help of this one, you can calculate the kinetic friction. So that is what Fk equals to. You can also write it as Fk equals to mu K into mass into acceleration due to gravity. Okay. So in general, mu K into N is going to be what? Is going to be your kinetic friction formula. Okay. So if they give the value of mu K and the mass, you can easily calculate what is the kinetic friction acting on that one. Okay. Suppose mass is not given. If they give acceleration of the body, you can what is the applied force, then also you can calculate what mass, and using that mass again you can calculate the kinetic friction. Okay, so we will see when we will take examples on this one. And again in kinetic friction we can broadly divide into two. Kinetic friction, again we can divide into two. What is that? So one is sliding friction, and another is rolling friction. One is sliding friction, another is rolling friction, because both possibilities are there. Sliding friction in the sense you can this body can only slide over the another body. This body can just slide over the another body. So this much area is in contact with what surface. So friction is what? Friction is more. Okay. But what the people used, when they got the wheels like circular shape. So what has happened? They felt when you want to move this one, there are 10 people are required to push it. Okay. So some 10 people are required to move it. But when this comes, your one person is also sufficient. If we just touch it, so it will move. It will come here without any apply of large amount of force. Why? Because here friction is more, because so much of the mass is in contact with that one. But here only at one point it is in contact with the surface. So that is why this became what the extraordinary invention of the discovery of the decade, because of the all motions becomes easy, and we can reduce the friction also. But there also some kind of friction is there. We thought we can reduce the friction, but there was some demerit. So because of that demerit, we got one more kind of friction, that is what the rolling friction. So about sliding friction and rolling friction, we have to discuss in detail. Enumerate the definitions of those two. What is sliding friction and rolling friction? Okay, so sliding friction. So what exactly is sliding friction? Sliding friction, when it comes in action, whenever a body is sliding, in both the cases body is moving. But here what is happening? A body is sliding on the another body. Okay, so what you can write? A force of friction which comes in action when one body, or when an object, when one body slides over another body, so that friction is called what is that? The sliding friction. Okay, so when an object or body is sliding on another body, so lot of the opposition will be occur. So that is what the kinetic friction only, but it is the sliding friction we can call it as. Okay, so in order to avoid this one, what they have done the round shape of the object. So in this case, the point of contact is only at one point. So the rolling friction, the opposition may be here less, because so many particles are attached, but here only one particle is attached. So that is why the friction is going to be the contact is going to be less. So what we thought, there we must have removed for friction completely, but it was not true. There was some the friction was existing. Why that friction was coming is when this body comes over here, what will happen? The lot of force will be concentrated at one point. When lot of force acted here, this surface become like this. Okay, so what will happen? There is a push of the surface. So because of that, what will happen? It will go little down. Now it has to travel what you can say some slight some inclined surface. For that again, what it is difficult. So that kind of the friction is coming in action. Again, opposition is coming because of its mass. mass is concentrating at one point. Okay, so that is why the another friction comes in action. What is that? That is the rolling friction. So how we can define the rolling friction? It is possible only when object rolls over another object. Okay, so let me write just a definition of this one: rolling friction. Okay, so what is rolling friction? The simple definition is a force of friction, which comes in action, when one body rolls over another body. When one body rolls over another body is called rolling friction. Definitions are also very simple, but we have to understand what exactly it is, how that friction is developing. Okay, because of the large amount of mass concentrating at one point, that is making that surface to little go down. So because of that, it is difficult for that body to move forward. Okay, so this is what all about the sliding friction and rolling friction. Still things are there to discuss about the kinetic friction that we will see in our next class.